All right, welcome to the Explainer. Today, we're getting hands-on with the Bombardier Q400 aircraft. Look, when the automatic systems are working perfectly, flying is a breeze. But when things go sideways and you need to step in and take manual control of the pressurization, you want to be completely confident, completely safe, and totally precise. So today, we are unpacking the exact procedures straight from the manual to make this complex system effortlessly easy to memorize and execute. Here is our flight plan for today. We're going to quickly walk through the basics, the exact procedure, some solid recommendations, and then we'll see how it all plays out across your climb, cruise, and descent scenarios.
All right, Section 1, the basics, when to take control.
So, first things first, when does the auto system actually hand the reins over to you? You can memorize this instantly using the MQLF trigger check. It's super simple. M is for MEL, like if you're dispatching under the MEL for the fuselage doors warning system. Q is for QRH, meaning you're running a procedure for a cabin press warning or failure. L is for a left main bus failure in the electrical system. And F, that's just the fault light lighting up right there on your pressurization panel. MQLF. Lock that in your head, and you'll never second guess when it's time to switch to manual.
Now, take a look at the layout right here. In the center right, you've got the auto man dump switch. That's how you actually transfer control. Just below it, that little man diff toggle switch. Honestly, that toggle is going to be your best friend. It's your primary tool for controlling the differential pressure. And over on the left, you've got the really important stuff, your monitoring gauges, your cabin differential pressure, your cabin altitude, and your cabin rate of change gauge.
Okay, before you even think about touching that man diff toggle, you need to picture what's happening mechanically in the back with the aft outflow valve. We've got two great memory rules here, ICD and DOI. Think of ICD like this. Hitting the toggle to increase closes the valve, which actually decreases your cabin altitude. Make sense? Then you've got DOI. Hitting the toggle to decrease opens the valve, lets air escape, and increases the cabin altitude. Increase closes, decreases. Decrease opens, increases. Keep those two straight and you are in total control. Moving right along to Section 2, the procedure. Simple and strict. So how do we actually do this? It literally couldn't be simpler. The manual gives us exactly 2 steps. Step 1, flip your auto, man, dump switch straight over to the man position. Step 2, grab that man diff switch and toggle to NCR or DECR as required by whatever is going on in your flight. Boom. That is the fundamental procedure right there.
Next up, Section 3, recommendations, pro tips for switch management.
All right, pay attention to this one because this is all about keeping your passengers comfortable and avoiding extreme pressure spikes. We call it the jab rule. You should absolutely always use the man diff switch in short, quick jabs of just 1 second or less. Why? Well, a single 1-second jab gives you roughly 200 to 500 feet per minute in your cabin rate of change. You literally never want to press and hold this switch down unless a specific checklist tells you to. Just give it a quick jab. It keeps everything smooth.
Now, right alongside the jab rule, you need to keep the 5-8 rule in your head at all times. You always use your differential placard as your guide, but these are your hard limits. Your maximum differential pressure is mapped to 5.46 psi, and under absolutely no circumstances should your cabin altitude ever climb over 8,000 feet. 5.46 and 8,000. That 5-8 rule is your absolute non-negotiable safety boundary.
Section 4. Climb scenarios, ground to altitude.
Let's put this into practice dynamically. Scenario 1, you're initiating manual pressurization straight from the ground up. Here's how it flows. On the takeoff roll, switch from auto to man. After takeoff, right at your acceleration altitude, establish your systems. Get bleeds 1 and 2 to on or norm and packs to auto. From there, it's on you to maintain a nice steady cabin rate of climb. You're aiming for 300 to 500 feet per minute using those short anchored jabs we just talked about. Just keep an eye on your cabin differential, watch it increase, and carefully follow your placard on the way up.
But what about Scenario 2? Say you're taking off from a high-elevation airport. Or worse, your auto mode suddenly kicks the bucket during your check around 5,000 feet. Priorities change instantly. First step, select Man mode. Then, immediately jab NCR to crush your cabin rate of climb down to absolute zero. At the exact same time, you need to level off the aircraft. Get on the radio, give ATC the appropriate call, and pause. Once you've firmly regained control of the pressurization, then you can continue the climb, managing the pressure according to the placard. And here is a really brilliant built-in safety buffer that the manual points out.
Maintaining a cabin altitude slightly higher than the exact placarded value, meaning you lean toward the right side of the aircraft's altitude chart, is totally acceptable. Think about it. If you're at flight level 150, the placard might say 1,800 feet for your cabin altitude, but letting it sit between 3,000 and 5,000 feet, completely fine. It actually results in a lower, safer differential pressure, keeping you miles away from that 5.46 psi limit.
All right, Section 5. Cruise parameters. Level flight.
Once you've finally hit your cruising altitude, you get a bit of a breather. The workload shifts from actively jabbing switches to diligent monitoring. Things stabilize. You'll still use the man-diff switch for tiny tweaks, toggling in-car or de-car as needed. But your main target here is stability. Your cabin rate of climb or descent should sit perfectly at 0. And as always, verify the 5-8 rule. Ensure your differential pressure does not cross 5.46 psi, and double-check your cabin altitude stays at or below 8,000 feet.
Which brings us to Section 6, Descent Operations, bringing it down safely.
All right, the descent. This is where you really need some foresight so you don't pop everyone's ears on the back. A standard descent is basically the climb in reverse. You want to aim for a comfortable target cabin rate of descent of about 300 to 600 feet per minute. You achieve this with very small toggle changes as the aircraft drops. Oh, and here's a massive tip. If ATC throws a step descent at you, you absolutely must reduce your cabin rate to 0 during those level-offs. Do not let the cabin keep descending if the aircraft is flying level.
Now, I need you to pay close attention here because this is a specific trap the manual warns about. Say you're cruising way up at flight level 250. Your cabin altitude is likely already maxed out at exactly 8,000 feet. When you start your descent from here, you actually have to jab INCR initially. Sounds weird, right? But jabbing INCR forces the cabin to descend right away so that as the outside pressure changes, your internal cabin altitude doesn't accidentally spike above that hard 8,000-foot limit. Don't get caught in that trap.
We're almost on the ground. As you approach your destination, you have one last critical task. Nobody wants a sudden pressure jolt when the cabin doors open on the tarmac. So before you cross 1,000 feet height above touchdown, start giving that DECR switch some jabs. You want to actively depressurize the aircraft until that differential pressure gauge reads less than 0.5 psi. Check that off, and you're set for a completely smooth arrival.
To tie this whole system together beautifully, there's a fantastic little trick from the manual to view your instruments. I call it the 2 C's rule. Well, sort of. Think of it like this. Your cabin rate of change gauge is your comfort gauge. You jab the switches to keep that needle smooth so the passengers are happy. But your differential pressure gauge, that is your ultimate safety gauge. That is what protects the actual structural integrity of the airframe. Comfort versus safety. You've got to balance and monitor both carefully.
So we've walked through the MQLF trigger check, nailed down the ICD and DOI mechanics, mastered the vital jab and 5-8 rules, and flown it through every single phase of flight. By sticking to these exact steps and relying on these memory tricks, handling the Q400's pressurization manually is an absolute breeze. Which leaves me with one final thought for you. In an era where flight decks are incredibly automated, isn't true airmanship ultimately defined by how smoothly you fly the plane when the computers finally hand the reins back to you? Thanks for joining me on this explainer, and keep learning.